Okay, welcome back. It's Chemistry B, Unit 8. This is Oxidation and Reduction. Day 3 of our Redox Equilibrium unit. Let's get started. Alright, oxidation and reduction. There are two kinds of definitions for oxidation and reduction. One involves what we're going to talk about here quickly, and the other one adds a little bit to the definition. So let's talk about what early chemists saw. Early chemists thought that oxidation was just a combination of an element with oxygen to produce an oxide, so an ion of oxygen. Okay, so early chemists saw oxidation as the combination of an element with oxygen to produce an oxide. Example would be the burning of methane, which is CH4, in the air. It oxidizes and forms oxides of carbon and hydrogen. Alright. Now, just because there's oxygen doesn't mean that all oxidation processes have to have burning. For example, when iron rusts, it slowly oxidizes to compounds such as iron oxide, Fe2O3. Alright? Another example of oxidation that does not include or involve burning would be the bleaching stains in clothes. Alright? Now there's a process that is called reduction, which is the opposite of oxidation. This is a loss of oxygen from a compound. The substance gaining oxygen is oxidized, while the substance losing oxygen is reduced. No oxidation occurs without reduction, and no reduction occurs without oxidation. Just like the song Love and Marriage, you can't have one without the other. Alright, later on, scientists amended, if you will, the definition of oxidation and reduction to include transferring of electrons. Alright? So the current definition of oxidation, or the most complete definition, is the complete or partial loss of electrons or a gain of oxygen. And reduction, the current reduction definition is complete or partial gain of electrons or the loss of oxygen. This new classification allows for the inclusion of many reactions which do not include oxygen. So now redox reactions involve the shift of electrons between reactants. So we have redox reactions that will form ions. During a reaction between a metal and a nonmetal, electrons, E negatives, are transferred from the metal atom to the nonmetal atom. That is a redox reaction. Alright, let's take a look at what we have here. We have a drawing of magnesium and sulfur reaction. Alright, over here on the left you can see magnesium with its 2 electrons, and it's going to combine with sulfur, which has its 6 electrons. The arrows aren't lined up. They used to be before we started, but I think you get the idea that the electrons are transferring to the sulfur, and that will produce a magnesium ion, and it is a 2 positive because it has lost its 2 electrons, giving it more protons than electrons. And the sulfur atom becomes a sulfide ion. It's 2 negative because it has 2 extra electrons. Okay? So the magnesium atom has said to be oxidized because it has lost its electrons, and at the same time the sulfur atom gains 2 electrons and it is reduced to a sulfide ion. So therefore, oxidation was the magnesium turning into magnesium 2 positive by losing its electrons, and reduction is the sulfur gaining the 2 electrons from the magnesium. All right. Now the substance which is losing the electrons is called the reducing agent, and the substance which is gaining the electrons is called the oxidizing agent. And then finally, when you talk about oxidation reduction, one of the major things that we need to be aware of is corrosion and how we can prevent it. Corrosion is when metals become oxidized to ions by oxygen. H2O or water will accelerate that process, so it doesn't actually cause it, it just makes it go faster. And now let's take a look at our example. We know that iron plus oxygen would eventually turn into rust, but we know that iron plus oxygen plus water will make that happen even quicker. Okay, it turns it into iron hydroxide, not just iron oxide like it normally would. So now corrosion can be controlled by allowing two metals to be in contact with each other, sacrificing one to protect the other. Example here, to protect iron, magnesium is placed in electrical contact with the iron. When the oxygen and the water attack the iron loses its electrons as it's oxidized. Magnesium, however, is a better reducing agent than iron, so the magnesium transfers electrons to the iron atoms, preventing iron oxidation.